Assalamu alaikum. Welcome to lecture number 41 for the subject of software design and architecture ITech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture, students, we discussed different principles which you should be follow while you are going to design a user interface, where we discussed some 12 to 13 different principles which are very important, and you should follow these principles while you are going to design a user interface for your target audience, and you should follow these important principles for the design of user interface. So students, what are the objective of our today's lecture discussion? Students, in this lecture we are going to discuss about two important aspects of cohesion and coupling in software engineering, what actually they are and how actually they affect our design and architecture. We actually see these cohesion and coupling, and we also discuss the different types and what actually they are, and we will discuss these cohesion and coupling in more detail. So these two terms will be discussed in this lecture. So let's formally start our lecture number 41 discussion. So students, before I start module coupling. So basically students, what coupling is. So you should note one thing: a good program should have minimized coupling and high cohesion. And whatever the program, if it has minimize coupling and high cohesion, and you should declare it's a good design and it's a good software. If any program or if any design or an application contains high coupling and minimize cohesion, it is a bad software or a bad design, you can say. So actually students, in module coupling we can say, in software engineering, the coupling is basically the degree of interdependence between software modules, and two modules that are tightly coupled are strongly dependent on each other. However, we can say like two modules that are loosely coupled are not dependent on each other. So uncoupled modules have no interdependence at all within them. So your module should have minimized coupling, which actually depicts the good design direction. So there are different types of coupling techniques will be discussed in later part. If you see in this diagram, here you can see in the figure A, this has no dependencies, because you can see it is not uncoupled. One node is not connected or not interacting with other module. So if you see in another diagram, there are some dependencies between module. So these nodes you can consider as a module. If modules are dependent between each other, these modules are dependent. In the figure B you can see that these different nodes are actually our modules, and these modules are interacting with each other and they are depending on each other. So these are the loosely coupled, and you can see that in the most right side diagram in the figure C, which are highly coupled and there are many dependencies. You can see how all of these modules are highly coupled with each other. So the A figure is most beneficial for our software design because it is not coupled, and as I said, the good program should have minimized coupling. And in this figure A, our module has no coupling, we can declare it has zero coupling. And if you see in this figure B, it not have zero coupling, but it has coupling up to some extent, you can say at moderate level, which can be acceptable. But if you can see in the figure C, this figure C actually representing the highly coupling between these modules, because you can see that these nodes or modules are heavily interacting with each other. These arrows actually showing that how these modules are actually interacting with each other. So figure A is not coupled at all, and figure B is loosely coupled, which may be acceptable in some cases, but figure C is highly coupled because these modules or nodes with the help of these arrows are actually interacting with each other heavily. So it's a highly coupled which we also known as many dependencies. So loosely coupled we have some dependencies, but in uncoupled system we have no dependencies. And a good software or a good design should have no dependencies, which you call uncoupled, or if it is in some cases it is not possible, or in mostly cases it is not possible to achieve zero coupling or no dependencies. There can be dependencies, so your design should be or must be loosely coupled. It only has some, up to some extent, dependencies. It should not have many dependencies, or it should not have highly coupled, because highly coupled system which will ultimately leads to a bad design. So your software or design should have minimized coupling between different modules, or no dependencies you can say, but you should avoid from this highly coupled or many dependencies interaction between different modules within a program or within a system. So it's all about coupling. So I can conclude about this module coupling. We can say a good design is actually is the one that has low coupling. So coupling is actually measured by number of relations between the modules. Like here in this picture we can see that we have four modules. In figure A, B, C we have four modules, and in these four modules in the part A we have no dependency, and in the figure B, in between these four modules we have some dependencies, and in figure C between these four modules we have very high or many dependencies. So no dependency mean a good design. So we can say the coupling increases as a number of calls between modules increase, or the amount of shared data is large. So we can say, or thus it can be said, that a design with high coupling will have more errors. This figure A, B, C is actually represented, as you can see in this figure C. These four modules are, you can see in this diagram, as a number of calls between these four modules are increases, and the amount of data shared is large in this figure C. So we can conclude that a design with high coupling will have more errors. And in this figure A we have no number of calls between these modules, and there is no data share between these modules in figure A, where we have no dependencies. So here we have a minimized coupling or zero coupling. So it's so this figure A actually representing a good design, and this figure C actually representing a bad design, because in this figure C you can see that between these four modules number of calls between these four modules increases, and the amount of shared data between this module is also large. So that's why this figure C is actually representing a design with high coupling, which actually ultimately you can say leads to more or high errors. So students, there are different types of coupling as well. So there are various types of module coupling as listed in this figure. So non-direct coupling, data coupling, stamp coupling, control coupling, external, common, and content coupling. So students, as we discussed earlier, coupling, what actually coupling is. So as we discussed about coupling, which actually shows the degree of interdependence between two software modules, is called coupling. So these are the different types of coupling. So the more we are near towards a non-direct coupling, our design will be best, and the more we will be ranging towards the content coupling, our design will be worst. The more near you towards the non-direct coupling, your design will be best, because it actually leads towards a minimized coupling. The more your design is ranging towards a content coupling, it will contain high coupling, and your design will be worst. So let me explain these terms one by one. What is actually no direct coupling? As its name tells about, there is no direct coupling between any modules. As we see in this diagram, in the uncoupled, this figure A is actually representing about no direct coupling. There is no coupling between these modules. So in the no direct coupling, you can say there is no direct coupling between any two modules. So in other words, we can say say modules can be subordinate to different modules, so therefore there is no direct coupling. So no direct coupling is the best coupling, where you can say we have zero coupling or minimized coupling, and it is the best coupling you should achieve in your design. And then one level higher coupling is data coupling. The more we will be ranging towards the content coupling, our design will be worst. The more we will be ranging towards the non-direct coupling, our design will be best. So in data coupling we can say about like when data of one module is passed to another module, this type of coupling is actually called data coupling. Or in other words, when you pass the data of one module in another module, for example you have two module, module A and module B, and if you will pass the data of module A into module B, this type of coupling we usually call the data coupling. And after data coupling we have stamp coupling. What actually is about stamp coupling? This stamp coupling actually about two modules are stamp coupled, we can say. Like in short, two modules are stamp coupled, like if they communicate using composite data items like structure, object, etc. So when the module passes non-global data structure or entire structure to another module, they are said to be stamp coupled. So structure, objects, all of these terms you have been already have been studied in your programming and object oriented programming subjects. So in short, when the module passes non-global data structure, or you can say entire structure, to another module, then these modules said to be stamp coupled. So for example, if you see an example, passing structure variable in C or object in C++ language to a module is an example of stamp coupling, where you actually pass your structure variable in C or objects in C++, etc. And the next is about control coupling. What is actually about control coupling? So students, control coupling exists among two modules. If data from one module is used to direct the structure of instruction execution in another, so this type of coupling we normally called control coupling. And the next coupling is about external coupling. What actually the external coupling is? So external coupling usually arises when two modules share an externally imposed data format, communication protocols, or device interfaces. So this type is actually related to communication to external tools and devices. This type of coupling we known as external coupling, where you actually impose different like data format, like communication protocols or device interfaces. This external coupling we can say actually related to communication to external tools and devices. And the next coupling is common coupling. What does it mean? Common coupling means two modules are common coupled, like if they share information through some global data items. So when information is actually shared by some global data item between two different modules, so these two modules are, we can say, common coupled, because they share information through some global data item. So this type of coupling we called common coupling. And the last type of coupling is content coupling. Student, this content coupling actually exists among two modules if they share code. For example, a branch from one module into another module is an example of content coupling, where you actually share your code from one module to another module. This type of coupling is called content coupling. So students, if you are more towards a non-direct coupling, your design will be best. If your coupling type is more towards a content coupling, your design will be best. So always try that your program design or code should have minimized coupling or no coupling. But must remember, your program will have some at least some coupling. So you should try, there should be loosely coupled, or there should be some minimum dependencies between different modules, because you should clarify your concepts here. A good program should have minimized coupling, and and if you are ranging towards a non-direct coupling, your program or system has minimized coupling. If your coupling is ranging towards a content coupling, so your program have high coupling, which are actually is the sign of worst design. And the next one is about module cohesion. So students, what is cohesion? So as we first we discussed about the module coupling, and now we are going to discuss about module cohesion. So students, in programming, actually cohesion defines to the degree to which the elements of a module belong together. So it is intradependencies. So the dependency between two module actually is called coupling, and the dependency of elements within a module is actually be known as cohesion. So this cohesion is actually, we can say, a degree to which the elements of a module belong together. So cohesion actually measure the strength of relationship between pieces of functionality within a given module. So for example, in highly cohesive system, functionality is strongly related. So cohesion is an ordinal type of measurement, and this is generally described as high cohesion and low coupling. And your program should have high cohesion, and good design should have high cohesion and minimize coupling. You should clear your concept here. Coupling is actually the interdependencies between two modules, while cohesion is the intradependency of elements within a module, which actually denotes the strength of any module. And this actually, we can say, cohesion is actually a strength of relations within modules. So your program should have minimized coupling and high cohesion, which actually strives for a good design. So students, similarly, we have also some type of cohesion as well, ranging from best to worst. You should try your best to achieve best cohesion, because if your program will have high cohesion, your design will be good. If your program have worst cohesion or minimum cohesion, it will lead to a bad design. So what type of cohesions we have? So like functional cohesion, sequential cohesion, communication cohesion, procedural, temporal, logical, and coin cohesion, coidentical cohesion. So students, these cohesions, you are more toward the coin cohesion. Your cohesion is actually a worst. If your cohesion is more towards the functional cohesion, your cohesion is best. So students, let me give you some detail about these type of cohesion. The first one is about functional cohesion, which is the best one. So we can say this functional cohesion is said to exist if the different elements of a module cooperate to achieve a single function. So this is actually about functional cohesion, or you can say the elements within a function which actually helps to achieve a single function is called functional cohesion, and this is the best cohesion. And the next is about sequential cohesion. Sequential cohesion is actually about, we can say, like you can say a module is said to possess sequential cohesion if the element of a module form the components of the sequence, like where the output from one component of the sequence is input to the next component. This type of cohesion we call sequential cohesion. So the important aspect is, in this sequential cohesion, element of a module form the components of the sequence, where the output from one component of the sequence is serves as the input to the next one. So this type of cohesion is actually we call sequential cohesion. And the next type of cohesion is actually about communicational cohesion, or communication cohesion, you can say. In this type of cohesion, like a module is said to have communicational cohesion if all tasks of the module refer to or update the same data structure. For example, like set of functions defined on an array or a stack which actually define the same data structure. So this type of cohesion we actually call the communicational cohesion. And the next type of cohesion is procedural cohesion. What does it mean? Your module is said to be procedural cohesion like if the set of purpose of the module are all parts of a procedure, like in which particular sequence of steps has to be carried out for achieving a goal. For example, the algorithm for decoding a message is a type of is an example for procedural cohesion. So the next one is about temporal cohesion. What actually the temporal cohesion? So students, like when a module includes functions like which are actually associated by the fact that all the modules must be executed in same time, and this module is said to be exhibit temporal cohesion which need to be executed at same time. So the next type of coupling is about logical cohesion. The next type of cohesion is logical cohesion. So students, logical cohesion, you can say a module is said to be logically cohesive if all the elements of the module perform a similar operation. What I say, if all the elements of a module perform a similar operation, is called logical cohesion. For example, like error handling, data input and data output are typical examples for logical cohesion. And the last one is actually about coincidental cohesion or coincidental cohesion. It's sometimes also called coin coupling, etc. Coin cohesion. So student, in this coincidental cohesion, a module, we can say, is said to have coincidental cohesion if it actually performs a set of tasks which are actually associated with each other very loosely, or you can say at all. So this is actually about coincidental cohesion. So students, these are the different types of cohesion which I explained you very briefly. So you should note one thing here is that coupling is basically the interdependencies between two modules, while the cohesion is the intradependency of elements within a module we call the cohesion. And you should clear your mind here is that a good design or program should have minimized coupling and high cohesion, and you are more towards the functional cohesion, you have a best level of cohesion, and you are more towards the coincidental cohesion, you are more towards the worst type of cohesion. So you should try in your program or code to achieve a high level of cohesion and minimum level of coupling. So this is all about cohesion and coupling. So students, here is a difference between these two terms, coupling and cohesion, to give you a broader picture about these two terms. Like as we discussed earlier, coupling we also call it intermodule binding, where we actually see how two modules are actually dependent on each other, while cohesion is the intramodule binding, where elements of a module are actually depending on each other within a module. So it's a intramodule binding, and coupling is a intermodule binding. And this coupling actually shows relationship between modules, while cohesion actually shows the relationship within the same module. And now the next one is actually the coupling shows the relative independence between the modules, how these modules are actually independent to each other, while the cohesion actually shows the strength of how much a module is relatively functional strength, how much it is actually dependent on its elements, which actually shows its functional strength. In this coupling, like while creating, you should aim for low coupling, as I said you earlier. While you are going to design your architecture or programming, you should strive for minimize coupling and high cohesion. You should always try to get high cohesion and minimize coupling. And the last point is actually about in coupling, actually modules are linked to the other modules, because the reason is coupling always exists between two or more modules, which we also known as intermodule binding. And in cohesion, module actually focus on a single thing, or you can say within a module of elements, where as we see, cohesion is actually about the intra-module binding, where different elements are dependent on each other. So in cohesion, we can say a module actually focuses on a single thing. So student, it's a difference between cohesion and coupling. So students, still here we discussed cohesion and coupling, what actually they are. We also discussed the different types in very briefly, and we also see the differences as well, cohesion and coupling. And this cohesion and coupling is very important in software design and architecture. So whenever you will design your first software, you should always try to get minimize coupling and high cohesion, so that you can achieve a good design. So students, still here our lecture number 41 is ended.